Let's solve the following system using Gauss-Jordan elimination. Our first step will be to build the augmented matrix. The columns will represent coefficients of x, y, and z, and over on the right side we'll have the numbers coming from our equations. So the top equation will be translated as 2, 6, 8, 12. And if we fill in the other two rows coming from our other two equations, we're going to get 3, 7, 9, and 15. And then 4, 4, 4 with a 7 over on the right side. Let's get a 1 in the upper left-hand corner. We could do that by dividing row 1 by 2. So we'd get 1, 3, 4, and a 6 over on the right side. And our other two rows will stay the same. And this 1 that we've just created is going to be our pivot that will allow us to get zeros in the rest of that first column. So to do that, let's take row 2 minus 3 times row 1. To eliminate this 3 here, we're doing the row that we're on minus 3 times our pivot row. And to eliminate the 4, we can do row 3 minus 4 times row 1. Our top row will stay the same. So if we do row 2 minus 3 times row 1, we're going to get 0. 7 minus 9 will give us negative 2. 9 minus 12 will give us negative 3. And 15 minus 18 will give us negative 3. Going down into the bottom row, if we do row 3 minus 4 row 1, we're going to get 0. 4 minus 12 is going to be negative 8. 4 minus 16 is going to give us negative 12. And then over on the right side, if we do 7 minus 24, we'll get negative 17. So that is our first column all completed. We can now move down and to the right and see if we can make this entry here equal to 1. So let's take row 2 and divide it by negative 2. Just a little caution when we're dividing by a negative number that our signs are going to be changing all the way across this row. So we just have to be very aware of that. We're going to get 1 and 3/2. And over on the right side, 3/2. And our top and bottom rows won't be changing at this point. So we've created a pivot of 1, and we can now use that pivot to get zeros in the rest of that second column. So let's do row 1 minus 3 times our pivot row, and we can also do row 3 plus 8 times our pivot row. All right, so starting with the first row, if we do row 1 minus 3 times row 2, we're going to get 1, 0, and then we'll have to do 4 minus 3 times 3/2. So if we just do our calculation underneath the matrix, this is going to be 8/2 minus 9/2. So minus 1/2 there. Okay, we'll also have to do 6 minus 3 times 3/2. So that's going to give us 12/2 minus 9/2, or in other words, 3/2. So any of these calculations that are a little bit pesky can be done either beside your matrix or below your matrix. We don't have to do these sorts of calculations in our heads. Second row will stay the same, so we'll just recopy that. And we can move down now into the bottom row. So row 3 plus 8 times row 2 is going to give us 0, 0. And then we'll have minus 12 plus 8 times 3/2. Well, we can cancel a factor of 2 from the numerator and the denominator. And this is going to be minus 12 plus 12. So we're just getting a 0 there. And for our very bottom right-hand side here, we're going to do minus 17 plus 8 times 3/2. And again, canceling a factor of 2 from the numerator and the denominator, we're going to get minus 17 plus 12. So negative 5 is what we would get there. So at this point, if we now take a look at our bottom row, if we translate the row of this matrix into an equation, what we're really saying is that 0 times x plus 0 times y plus 0 times z is equal to negative 5. In other words, 0 equals negative 5. This statement here, this is impossible. There are no x, y, and z values out there that are going to make this true. And this is telling us that our system has no solution. So that is the end of the problem. It's good to write down system has no solution, so it's clear that we understand that we cannot solve this system. And just as a little reminder that whenever you see a row of zeros on the left and something non-zero on the right, you're getting an impossible statement that cannot be true. So 0 equals negative 5, not going to happen for any values of x, y, and z. At that point, the problem stops and we say the system has no solution.